Hello everyone. So let's discuss the first question of CP contest, that is name trouble. So the problem statement reads as follows. Company ABCD has received many internship registrations. There were many duplicate names received. The company has asked you to remove the duplicate registrations and print the final count of names in the name list after removing the duplicate entries. So it says that a company has received some internship registrations, like some registrations, and there were some duplicates in that. So some students applied for the same internship many times. So the company wants only the unique, or wants to remove that duplicate registrations and finally print the number of unique entries in the name list. The input format says that we are given an integer n, that is the number of registrations, and in the next n lines we are given the names which are strings. The constraints are the number of registrations is less than 2 into 10 power 5, and the string length is less than 100. And what we have to output the number of elements after removing duplicates. So for the sample input we are given 5 entries, and the names given are alpha, beta, gamma, gamma, alpha. So the alpha is repeated 2 times, so we remove the last entry, and the gamma is also repeated 2 times, so we remove the gamma. So unique entries we have is alpha, beta, gamma. So the answer is 3. So if we think about the approach to this solution, we the first thing that comes to our mind is we can have a list or an array, and we for every element we add that for every element we check if that particular string is already present in the list or not. If it's present, we will skip that element, and if it's not present, then we will add that element into the list, and finally after all the iterations we will print the length of the list. But in this approach, we for every element we are checking if the element is present in the list or not. So for n numbers, for n strings, we are checking, we are traversing the list every time. So the time complexity, the worst case time complexity in this case will be O of n square. But since the constraint are 2 into 10 power 5, so our this approach will not be suited for this question. What better approach can be used is whenever we think about unique things, like we can only have unique. The first thing that should come into our mind is sets. So in set there cannot be any duplicate entries. So every language supports set in one way or other. In Python it is called set. In C++ we also have sets. So we can have a set, and for every string we can add that element into the set, and finally we print the length of that set. So if a element is repeated again, that element won't be added into the set again. So now we code the solution first in Python. So we declare a set, then first of all we take an integer input, the number of strings that we are given. Then we iterate for that n number of times, and every time we get a string input, and we add that string into our set, and finally we print out the length of that set. So that's all. We run this code. Okay, so our test case passes. Let's submit this code. Okay, so all our test cases pass. So now let's code the same solution in C++. So in C++, first we declare a set of strings, then we have an integer input, we take that input, and then for n number of times we declare a string, we take its input and we add that particular string into our set, and finally we print out the strings, the set size. So let's try to run our code. Okay, so there is one error. Okay, so I need to include the header library that has sets in it. I will include the bits library only, so it will include all the libraries, and I don't have to include these. The bits library already includes all the libraries. Okay, so there is still an error. Okay, sorry, I did set string. Okay. Okay, so our test case pass. Let's submit this code. Okay, so all our test cases pass. So that was the solution to this problem, name trouble, and the time complexity of this code will be in the better optimized approach by using sets is O of n, and the space complexity will also be O of n because we have used a set and use it to store the n number of strings. So that's all. Thank you.